Hello, Legacy students. Marsh here. We're going to look at inverse functions today. You're going to want those notes that I printed out for you, and then a pen or a pencil, and then you may need a calculator to do some simple calculations. What's an inverse? First definition. So the inverse, basically all it does, it changes the x and the y values. It flips them around. So x's become y's and y's become x's in a value of set points, or even in the equation, the x will become the y and the y becomes the x. What it basically is, what the basic idea of an inverse is it switches the x and the y. So basically it's a reflection over the line y equals x. So I have this original set of arrow points. This makes this arrow set right here. So these points right here. Now, to find my inverse of this arrow, all I'm doing is I'm going to flip my x and y's around. So the point was 4, -8, so my inverse would have a point of -8, 4. And I'm going to do that continually to fill this out here. There we go. And then I'm going to graph those points. Let's see what kind of graph I get. So it would be -8, 4, -5, 4, -5, 3, -3, 5, -5, 7, -5, 6, and -8, 6. So this would be the following graph I would get. Notice, basically all this is doing is it's taking my graph and it's flipping about the y equals x axis. Because it's basically saying change the y and x around and you get a reflection across the y and x. So let's graph the function and then let's graph its inverse. You're going to want two kinds of colors, or one pencil, one marker, or something like that, so you can tell who's the regular and who's the inverse. So let's create a table here. I'm going to go -2, -1, 0, 1, and 2. I plugged them into my function here using my calculator. When I plugged in a -2, I got 12. Plugged in -1 for my x, so that'd be -1 cubed, -1, positive, 5, because 1 plus 4 is 5. Got 0, for 0 I got 4. For 1 we got 3, and for 2 I got -4. So I'm going to graph my function here. So -2, 12, that's going to go kind of like about right there. -1, 5, 0, 4, 1, 3, and 2, -4. So it does a graph something like this. Cube function, it's definitely what it should look like there. Now I'm going to change my color so I can do my inverse of this guy. So my inverse, basically all it's going to do is it's going to do an x, y chart, but my y's are going to become my x's and my x's are going to become my y's. So I'm just going to write my chart off to the side here, just so I can make sure I graph my points correctly. You do not need to do this on every problem. However, just to show you that I'm flip-flopping my x and y's, and I find I kind of get confused if I don't. So I'm going to go 12, -2 for my first point, about right there. 5, -1, 4, 0, 3, 1, and -4, positive 2. So notice, guys, my graph is a cube root function. Graph of a cube root is the inverse of my cubic function. That's kind of interesting. But if you think about it, a cube root is an inverse of cubing something, right? So now, is this a function? Do you remember, back from the beginning of the year, it's far back, but we can do it. Do you remember how to tell if it's a function? Remember, it was taking our pencil and running it across our graph and thinking, do I have any time that my x's double up, or do I cross this graph more than once? And the answer is no. It does not cross more than once. So this is indeed a function. And the reason, it passes the vertical line test. Okay, let's try one more graph. So I got negative 2x squared plus 1. So I filled in my graph here. So negative 2, negative 1, 0, 1, and 2. Plugged in negative 2, and I got negative 7. Negative 1, I got a negative 1. 0, I got 1. 1, I got negative 1. And 2, I got negative 7. Because it's a parabola, right? So let's graph. Negative 2, negative 7. It looks like it's an upside down parabola. Negative 1, negative 1. 0, 1. 1, negative 1. And 2, negative 7. So I got a graph like this for my original. Now I'm going to change my color here. Let's go purple. So I'm going to do my chart here so I don't get confused and flip-flop my X and my Y around. Oh, that should be a 1. See, that's why I definitely write my chart here. So negative 7, negative 1. Negative 1, negative 1. Look, they share a point. That's kind of cool. 1, 0. Yeah, no, I'm right. Negative 1, 1. Negative 7, 2. Thought I messed up there, but I actually didn't. So I got a parabola laying on its side. Guys, look. This is like two square root functions together. That's kind of interesting. But now, is this a function? Look, guys, I have duplicate x's. Remember, on a function, if we were looking at ordered pairs, you couldn't have duplicate x's. Notice also, if I draw a straight vertical line through here, I'm going to hit my graph twice. So this is not a function because it crosses twice or there's multiple x's in my chart for my inverse. Now, let's find inverse when we don't have a graph. So, we're going to interchange the x and y. Just like we were interchanging it on our table, we're going to interchange it on our equation. So my y is going to become my x, and my x is going to become my y. Now, you need to solve for y. So, basically, you're going to start solving as if y was not solved for originally. So I'm going to get x minus 5 equals 3y. Looks like I got to divide by 3. So I'm going to be left with x minus 5 divided by 3 equals y. You could also write that as x 1/3 x minus 5/3 equals y, but I'll be okay with this as well. Okay? This one, now interchange so we can find our inverse. So I gotta flip-flop my x and y around. Few kids struggle with this. So you can't add 5. You gotta get rid of this division first. So let's multiply both sides by 3. And I'm going to get 3x equals 4y minus 5. Now I can start solving for y. So I'll add 5 on both sides. We get 3x plus 5 equals 4y. Divide by 4. And I have my answer. 3x plus 5 divided by 4 is equal to y. Not too bad, right? Pretty easy. Just flip-flop x and y and you got it. What about these two? So notice I got cubic function here. Let's find its inverse. So I'm going to flip-flop my x and y around. So x equals 3y cubed plus 5. So let's start solving for y. So I'm going to subtract 5 on both sides. Get x minus 5 equals 3y cubed. Looks like we need to divide by 3 because I need to get y cubed alone. So I got x minus 5 divided by 3 equals y cubed. But y is not alone. It's y cubed. So how can I do the inverse of y cubed? What would be the inverse? Well, if that was y squared, we would have square rooted, right? So why can't I cube root it? Let's cube root. So I'm going to cube root both sides. So I'm going to have the cube root that side and that side. So my final answer is the cube root of x minus 5 divided by 3 equals y. Am I denying that that looks kind of gross? Nope, it is. But nevertheless, these two are inverses of one another. Now, let's find the inverse of y equals 2x squared plus 1. So just like the last couple, flip-flop the x and y around. Now, start solving for y. Looks like subtract 1 first here. So I'll get x minus 1 equals 2y squared. Divide by 2. So I got x minus 1 divided by 2 equals y squared. Now, square root both sides. You're going to forget this. Please, please, if you square root something, you got a plus or minus in the front, right? Because you square rooted 9, you got plus or minus 3. Don't forget to put the plus or minus in front of your square root, okay? Because you need that positive version and the negative version to get the parabola laying on its side, kind of like the graph did when we were doing our graph of the inverse of the parabola, and it was laying on its side. The plus or minus allows you to get that parabola laying on its side, okay? So, summary. In your notes, that little end summary, how do you find an inverse? To find an inverse, basically, switch the x and y around, solve for y. How do you graph an inverse? Switch the x and y in each point of the original. So basically, make a new table, make your x's your y's your x's, and graph. Is it a function? How are you going to decide for the inverse? So, to tell if it's a function, you're going to see, does it pass that vertical line test that's so important? Basically, are the x's repeating at all? If they are, you do not have a function. And that's the end of this video. See you later, Sabers.